Hi, and welcome to Chapter 9. In Chapter 9, we're going to be covering two concepts called dictionaries and sets. Both dictionary sets are similar to lists in that they will hold a collection of information, but they both have some extra little things about them that make them very useful in Python. Let's get started. So the first thing we're going to cover is what is a dictionary. A dictionary is considered a key value pair. When we were dealing with indices in lists, we were dealing with the individual items and where they were in the list. In a dictionary, we give it a key. So this is similar to opening up a dictionary, those things with books that used to have words in them. And you would find the word. And when you found the keyword, you could find the definition for that word. In this case, a dictionary is the same thing. You're going to be looking up a key, which is generally a string, and being able to associate that with a value. When we talk about dictionaries, the value can be anything, including other lists, but the key has to be an immutable object like a string. So you can have a key like ABC, you can have it be Bob, Mary, Joe, and each of those keys has values that are associated with it. A lot of times it's just a single value, sometimes it's a list of values, sometimes it's an object. We'll talk about the different possible options for values when we get a little into other objects, but you can store other lists, other dictionaries, you can have them nested. When we talk about a list, things were always in an index location. In a dictionary, they're always in a key location. So we like to call dictionaries key value pairs. And those are often called mappings in the sense that for each key, there is a mapping to a value. When we do this in computers, we're actually storing with the key a location to where another piece of data is. So we're actually mapping that other piece of data. That's why we call it mapping. So the dictionary, you can think of it as a list where instead of having indices, we have keys. When you want to create your dictionary, we're going to use a different notation a little bit than what our lists were. When we did lists, we did brackets. When we do dictionary, we do curly braces, which are just a little bit different. And it does have to be a curly brace because that will tell Python that it's a dictionary and not a list. We will give it both the key and the value at the same time with a colon between the two. So key and then colon and then the value. And you can store multiple options or multiple elements in your dictionary at the same time by putting a semicolon in between your key value pairs. So I could store 5 different items. In this case, I give an example of a phone book with 3 where I have Chris and his phone number, Katie and her phone number, and then Joanne with her phone number. So each of these different key value pairs is being stored into the dictionary phone book. Yes, you can create an empty dictionary. If you're planning on creating a dictionary and then adding items to it as you go along, you might want to just start with nothing. Create an empty dictionary and then add items as you go, which is fine. You can create an empty dictionary by just doing open and close curly braces, and that will tell Python it's a dictionary, treat it like a dictionary. When we want to get the value out of the dictionary, we simply call the dictionary name, the variable name that we've used for our dictionary, and then our square brackets like we did with lists for our index, but instead of giving the index, we're going to give the key. So we're going to do our dictionary bracket and then our key name, and then close bracket, and that will return the value that exists in the dictionary. You can store that key value as a variable. So in the example here, I have John Smith as the key, and then I can just say my dictionary and then put the variable name my key in there, and it'll use that as a key, and it'll pull the value out. If you try to find the value in a dictionary for a specific item that does not exist, it will give you back a key error, which simply says there is no key that goes along with the key that you entered. So there's no value I can return for you. And instead of just returning null or returning something else, it will actually throw an error. We talked about throwing errors. As a way to get around those errors of throwing key value errors if the value does not exist in the dictionary, we use the in operator. So I can check with a Boolean expression to find out if the key exists in the dictionary. I can also find out if the key does not exist in the dictionary. This actually happens a lot if you don't know whether you want to add an item to a dictionary or not. If you try to insert a new item is going to clobber the item that exists there beforehand. So it's really important that with our dictionary, when we that we check to see whether that value exists already. We can use I've given an example here as an if, as a conditional. If the key is in the dictionary, then go ahead and get the value. If it's not in the dictionary, then print that the key is not found. So these are ways of checking to see whether or not the value exists in your dictionary. When we want to add new values to our dictionary, we use the syntax of being able to say my dictionary and then those brackets, those square brackets, and the key name, and then we're going to make that equal to the value that we're going to use. In this case, I just have my value as a variable, but you can use a literal at this point as well. That's fine. If the key does not exist, remember, we're going to throw that key value error. You can't have duplicate keys. So if I try to put in a phone number for John and there's already a value there for John, it will clobber that previous value. It'll just overwrite it immediately, and it won't yell at you. It won't tell you anything. So you want to check before you clobber a value in a dictionary and just say, does it already exist? And make sure that you do what you want to do correctly at that point. Because if you just clobber the value every time, you might end up with some problems with your data. If you have an item in your dictionary that you don't want to be in your dictionary anymore, you can delete that item by using the del or delete command. So we can just say del and then put in the dictionary and the key, and it will delete that item out of the key. You do not need to delete the entire dictionary in the sense of if you want to replace the variable with a new thing, you're welcome to. But remember, with Python, we don't have to unallocate that dictionary. It's fine. If you think that the dictionary isn't necessary anymore, you can just not use it anymore, and you should be fine with Python. In some other languages, you would want to deallocate that dictionary because dictionaries can take up a lot of data. But in Python, you don't really have to. If you try to delete an item that does not exist, again, you're going to get that error, that key value error saying, I can't find the key. So you always want to check to make sure that the item exists first. This slide has a lot of other dictionary methods and functions that you can use. I'm going to go through a few of them to try to explain to you what they do. But it's really important for you to understand that these are things that are just there for you to be able to use to make your life easier when working with dictionaries. The first is our length operator. Obviously, we have a length the same way that we do with lists. So we can just use our len for length of the dictionary, and it'll return how many items are in your dictionary. So if you remove items, add new items, you can use the length to find out what the length is. Dictionaries are mixed type, meaning that you can have multiple types of values in there. However, your keys have to be immutable, which means they cannot be changed. So remember, strings work for that and literal values work for that as well. So I can put in an employee number of like 1, 2, 3, and that would be fine as a key. You can also enter in any string value as a key. The value itself can be anything. So I could have a dictionary that has, for one key, it returns a number, and for another key, it returns a string, and for another key, it returns a Boolean. So I can have mixed types inside my dictionary, and that's fine. This happens a lot if you want to store like a address information, and you want to have a key that says address and a key that says steady state zip, key that says phone number. Well, obviously your zip code is going to be a number because it's five numbers. You could make it a string. Phone number again could be 10 characters, or it could be a number as well. So we can have mixed types in our dictionary, and that's fine as long as our keys are all immutable. We can use the looping to be able to walk through our list. So we can say for var variable, whatever variable you want, in my dictionary, and that will return the keys of that dictionary. It does not return the values, it returns the keys. Then you can reference each of the individual values by looping through, by getting that key value. So you can say, give me the value at this key, give me the value at this key, give me the value at this key. It doesn't give you the values, it gives you the keys. And that's a really important distinction with dictionaries, whereas for lists, it returns the item. In the dictionary, it returns the key. The other methods that we cover here are the clear method, which just clears your entire dictionary, the get method, which gets you the value with the key. It's the same thing as using the square brackets. It's just using the .get as opposed to just using the brackets. There are items and values, which returns a list of the items. all of the keys, and then it returns a list of all of the values. If that's something that you want, if you need to get all of the values that are in there and you don't really care about the keys, you can just get the values, and that's an option. We also have the pop item and pop methods, and those are just ways of getting pieces of information out of your dictionary and removing them at the same time. So we talked about how to remove them. This takes the item, returns the item, and removes it. So you can do this a lot if you were doing a deck of cards and you wanted to pop the top item off the stack. You could use a dictionary for your deck of cards, but then you would pop the item to take it out of the list. So pop and pop item will remove the item from the list and return it. At this point, I want you to stop the video for a second and go do the You Do It on page 452. This one is going to simulate a deck of cards. So I've been mentioning cards a lot. It's going to create a dictionary of cards, which also gives you the hand value or the face value of the card. An ace is a 1, and then any of the face values are a 10. Depending on which game you're playing will depend on that. But if you were saying blackjack or something like that, where you've got an ace as a 1 and a jack, queen, king as 10s. So in our dictionary, we have the key, which is going to be the name of the card, and the value, which is going to be the card value. If we were doing the homework assignment that had to do with blackjack, you would definitely want to do this first because that would be part of that assignment. It's not the assignment this semester, but you may still want to do the project because it's kind of a fun one. All right, so hopefully that got you a little bit of examples in how to use dictionaries. The next part of this chapter is in how to use sets. So sets are a little different than dictionaries. First off, sets do not have any ordering. They do not have any keys. They do not have any indexes. What a set is a collection of unique values. Unique meaning that you just can't have duplicates of the same value. If I was putting numbers in there and I tried to add 1 twice, it wouldn't yell, it wouldn't care. It would only keep one value for 1 though, because it keeps only unique values. It is completely unordered, which means that depending on the time of day and sunspots, you might get the items out in an order that is different than the first order. What they do is they hash it and it does it into a specific ordering that goes in the code, but you won't be able to recognize that. And it might change based on, again, sunspots. There are no duplicates, and you can have different data types as well. Again, things get hashed to figure out the ordering that it prints out at, but it's completely unordered. You never refer to a specific item in a set by its index or even by a key. So you just create the set. But for set operations, that's okay. And you'll see the different ways that we can use sets, and you'll do a couple homework problems with them as well. So sets are different than lists or dictionaries in that there is no ordering, there is no index, there is no way to retrieve a singular value. There are a couple of different ways that we can use to create a set, but they all kind of fall from the base entry of we use the keyword set, which is a function. And so we can say my set is equal to, and we use the function set because sets are different than lists and dictionaries, and we need to tell the compiler what type of object we want. So for a set, and then we use parentheses because it's a function like a regular method. So we have set and then open and close parentheses. Now you can create an empty set which has nothing in it with just open and close parentheses, or you can add a list of items. It has to be a list, so it has to be in square brackets of items. So in this case, I have set A, B, and C as 3 different items that exist as individual characters in a list, and it will create the set of ABC. Set notation when you're printing of a set comes in curly braces. That's how you know that it's a set versus a list when it's printed out. We can also just put in a string, and remember a string is just kind of an array or a list of characters, so it's essentially a list of itself. It's going to be able to split that A, B, and C into individual characters, and again we'll return A, B, and C as your list. If I wanted to put in A, B, 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 C, 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 that's fine. You're still going to end up with just A, B, C because there are no duplicates. It will look at the second A and go, already in there, don't care, ignore you. Look at the third A, don't care, already in here. Okay, B, okay, I'll add that one, but the second B, don't care, it's already in here, keep moving. And you'll only get the individual unique items as opposed to all of the items that you entered. If we wanted to do set without putting things in a list, it will fail. You need to put them inside of a brackets, but you can enter a single item with open and closed brackets. It's just a list of one item, and that's fine. You can add that to a list. We'll talk about that in a second. If we wanted to do set with 1, 2, and 3 separated by spaces, yes, you can do strings, but remember, strings are going to get a list of characters, which means when it sees the second O, it's already going to say there's already an O in there, and you are going to get ONE space TWHR, because those are the individual characters in that string. Remember, it's all unique. Which unique value do you have? If we want to add and remove items to our list, we use the add method name. So we would say my set, whatever my set was, dot add, and we can put in individual items at that point. We can do update, which is being able to add multiple items at a time. Adding, if you wanted to do the update with a singular item, you can put a single item in brackets. But you might as well just use the add if you were going to use that. But the update takes a list the same way that the constructor for a set does. So you need to have the parentheses and you need to have the list notation of the square brackets to be able to add multiple items. If we want to remove singular items, we can just say remove. Now there's a difference between removing and discarding in that discard will also remove the item. But when you try to remove an item that doesn't exist in the list, you will get a key error. Again, same way we did when we tried to remove an item that was not in a dictionary. It's a key error that essentially says, I think it's item error, that item doesn't exist. We can't do anything with it, and we're going to error out at you. If you want to discard it or remove it, regardless of whether it exists, you can use the discard method. And what the discard method says is if the item exists, remove it, but if it doesn't exist, I don't care, move on. It's kind of nice to have both of these options in there because as you're writing your code, you're going to pick different reasons to do things. Sometimes you're going to care whether there's an item in there and sometimes you're not. So being able to use the remove and the discard depending on your situation is going to be important. The same way that we used loops to walk through our dictionary, we can use loops to walk through our set. However, in the case of a set, there is no ordering. You cannot guarantee the ordering at all. In this case, I put in ABC and I came out with CBA. It went backwards. Sometimes it comes in with BCA, sometimes it comes in with ACB. It depends, and it'll change as things go. So you can't guarantee the ordering based on how you enter them, and that's fine. That's how sets work. But you can use a for loop. The for loop, obviously the variable in this case is going to return the value itself, not an index or a key or anything like that like we do with dictionaries. So sets just returns the variable that is the item in the key in the set, and you can print that directly. Again, we also have the in and not in to determine whether or not the value exists in the set. Same way we do with dictionaries. You can say if A is in my set, true or false. Is A not in my set, true or false. And those return a Boolean expression. So you can use them in an if statement, or you could use them in any other situation where you need a Boolean expression, you know, true, false value. One of the great things that we have about sets is our union intersection difference concepts. If you have taken any higher order math classes, you'll understand about set theory, what sets are. The reason why we like sets is because in Python, we have implemented that set theory concept in programming. Mathematical operations that help you find where do the two items, the two lists intersect, where do they have the same value, where do they have different values, what items are in both, what items are some, what not the other. So we have 4 different set theory applications that we can do with our sets. The first is a union. Union is give me all of the items that exist in A and all of the items that exist in B. So if I have 2 sets, give me all of the items that are both of them. And the shortcut for this is a bar. It's the pipe. It's the one directly above the enter key with a shift. So it's just a straight line. We call it bar, we call it pipe, we call it a couple of things in programming. But that symbol is the OR union symbol, which says give me all of the items from both sets. So I can say given set 1 and set 2, give me the union of the 2, and that will allow me to get all of the items that are in both of them. You can also use set 1 dot union with set 2, and that works as well, but I find that the shortcuts work really well. I like those. They make my code smaller. What we actually call the opposite of that is the intersection. So if you think of it kind of as a Venn diagram where you have A and B, your union is everything that's in both of them, whereas your intersection is just that little section between the two that covers items that are in both. So the union, or the intersection specifically, is give me all of the items that exist in both sets at the same time. And the shortcut for that is the and, the ampersand. And we can use that to find the intersection, or the logical and, of two sets. The third one is subtraction, or difference. We call it difference, but I always think of it as subtraction because that kind of makes more sense in my head. If I have a list, if I have list A and I want to subtract list B, it means take all of the items that exist in list B that also exist in list A and remove them. So it's kind of like if you were looking at the union or the Venn diagram again, and you had all of the items that exist in group A except the ones that exist in both. That's the subtraction. Subtraction is order matters. The same way subtraction in real life, if you had 10 minus 3, that's different than 3 minus 10. If I had subset A minus subset B, it's different than subset B minus subset A. Subset B first says give me all of the items that exist in B except those that also exist in A. The shortcut for this is the negative sign because it's a subtraction. We're doing a logical subtraction between two sets. The last one is what we call a symmetric difference. This is give me all of the items that exist in both A and B except those ones that they have in common. I also say this is a union subtracting a difference, or subtracting an intersection. So union and difference, intersection is give me a union, give me all of the items that exist in both of them, and then take out the items from that they had in common, the ones that were in that middle intersection. And you can see the examples that I've given here that show you, given these two sets of 1, 2, 3, 4, and then 5, 6, 7, or 3, 4, 5, 6, what are the values of each of those mathematical operations on sets? So hopefully this is actually, again, part of your homework of being able to do the union and the difference and the intersections of different sets. So I hope that this one makes sense. There are two more set notations that refer to subsets and supersets. So if you have a set, so you have 1, 2, 3, 4, and you have another set, just 2 and 3. If I want to find out if my set is a subset of the first set, can I take a grouping of some of the items that are in the first set and create my entire second set? Is it a subset? So we have, is it a subset? Is it a superset? Essentially says, are all of the items that exist in my set existing also in this other set? So in this case, I have set 1 and set 2. I've run is superset and is subset on both, and then showed you the answers of true or false so that you can see I've given the set 1, 2, 3, 4, and then 2 and 3. So yes, it's a superset. Yes, no, it's not a superset. Go in the other direction. Supersets and subsets are usually opposites of each other. So if you're a superset one direction, you would be a subset the other direction. Shortcuts for these are greater than or equal to sets, because you could have two sets that were equal, and those would be also supersets and subsets of each other if they were this equal sets. A superset has more items than just the other one, so that one would be a greater than. The subset has less items than the other one, less than or equal to. So that's why those are the shortcuts that we use for supersets and subsets. Remember, these are Boolean operators. They will return either true or false. They will not return a value. They will not return a set. They will return a true or false, a Boolean. The last section of chapter 9 covers a concept that we call serializing. When you store objects in text, in a file, you don't store them as just text, because that doesn't work. We have to store them separately because they are an object and they have different attributes that go along with them, and we can't just make them a string. A lot of the things that we've been storing in files have just been strings, which is really easy to do. But sometimes you want to store something that isn't a string, and we need to serialize it. This is done in any programming language where you're storing something that is an object rather than something that is a literal or a primitive type. Strings, numbers, Booleans, those can all be stored as straight text. But if you have an object and you need to store it, you can't store it as a straight text. You have to serialize it first. And when we serialize it, we convert it from whatever object it is into bits, into bytes, into data that the computer can read. So serializing is really important when we're working with objects like lists, or like dictionaries, or like sets. If we wanted to store any of these, we have to serialize them first. It creates a stream of bytes that can be reread in and then understood. In Python, we use a concept called pickle. And I know it sounds kind of funny, but if you think about what we do when we pickle vegetables and fruit is we kind of mush them down and we let them sit and brew. Someone along the way came up with the word pickle, and that's the name of the module, and we just go with it. So we use the library that's called pickle, and make sure that you import it first, the same way we do with turtle, the same way we do with random. The two operations that we use are the pickle dump and the pickle load. Those are the two main ones. There's other operations you can pickle as well. But these are the two big ones that we're going to use. When we dump, what we're going to do is we're going to do pickle.dump, and then we're going to add the object, and we're going to add the file, and it's going to save that file into the save that object serialized into the file. Usually store it as a data file, a DAT, as opposed to a TXT, because you can't read it. It's intentionally. You're not supposed to be able to read it. It's in bits. But when we get that file back and we want to load it, we can say pickle.load, and that will give us back our object. So for each object that you're going to create, you're going to put in a different file because you need to be able to load the object individually. So you have to be careful about how you're going to store your objects. But in this case, when you store your object, you use the dump command, and when you load the object back into memory so that you can use it in your code, you use the load, and that will store it as the object. There are two really good programs in the book that walk you through how to pickle with the exact syntax. I really highly recommend you go do it right now before you move on to the homework. Programs 9.4 and 9.5 on 475 through 479. You'll practice doing the pickle. You'll make sure you import it. You get the data in, you get the data out. We do have a homework assignment using pickle, so it's important that you understand this one as well. All right, so that is all of Chapter 9. Your homework, obviously, is Chapter 9 quiz. And then for homework, for programming assignments, 1 and 2, which deal with dictionaries, 5 and 6, which deal with sets, and 8, which involves the pickle. Really important PSA, public service announcement. If your code is exactly the same as code that is in the internet, you won't get any credit for it. I've been having some trouble with some students who seem to think that if they just go onto the internet and copy it straight from the internet, that's okay, and it's not. It's really important that you type this code up yourself and you actually do the projects yourself. Otherwise, why are you taking the course? You're not going to learn anything. So please, you can use the internet if you have to, but don't think I don't know that those sites are out there. You can literally go onto them and get your entire project. I'm checking plagiarism, checking on every assignment that comes through, and if you have copied, I'm going to give you a 0. So just a quick public service announcement to be aware. All right, have a fabulous week, and I will talk to you soon.